Hello everybody, I'm Elif Firat from University of Nottingham. I'm going to be presenting our paper Treemap Literacy, a classroom-based investigation. This is a kind of view of what I'm going to talk about today. First, I'm going to give you an introduction to the topic and some related works. Also, I'm going to talk about challenges of interpreting tree maps and Treemap literacy assessment. Then I'm going to introduce our Treemap literacy test and pedagogical Treemap tool. I'm going to talk about classroom evaluation and the results of the quantitative and qualitative analysis. Finally, I'm going to talk about some limitations and future work. I would like to start with the question of what is visualization literacy? A simple definition is the ability to interpret and understand visual designs. Visualization literacy has gained recognition in the educational and information visualization communities because visualizations are becoming a fundamental part of the education. However, enhancing the educational process with graphical representations and promoting visualization literacy are important goals. We wanted to study Treemap visualization. It is an efficient way to represent hierarchical data and requires a special layout algorithm. But displaying the large hierarchical data sets increases the complexity of the tree map, causing difficulty in tree map comprehension. Contributions. We aim to identify barriers to enable a complete literacy of tree maps. We investigated the barriers to tree map understanding and literacy. We developed a Treemap literacy test. Also, we designed a novel pedagogical application. This application facilitates both teaching and learning of Treemaps and advances Treemap visualization literacy. Related works. There are several works focused on improving visualization literacy. I will mention some of them as an example. Boy et al. Developed a method to identify users' visualization literacy level. Alper et al. Introduced an online platform to improve visualization literacy for early education. Another work by Kwon and Lee focused on teaching parallel coordinates, while Fuchs et al. Introducing a tool to use for both learning and teaching clustering algorithms using scatter plots. The last one is Lee et al. Presented visualization literacy test containing the most frequently used visual designs. The challenges of interpreting tree maps. We identify and study the challenges that prevent users from interpreting and comprehending tree maps correctly. We came up with 5 barriers to this successful tree map interpretation. The first one is hierarchy. One of the barriers to the tree map literacy is based on the fact that the tree map conveys hierarchical data. The tree map displays the relationship between hierarchically structured data attributes. The second one is layout. It aims to increase the visibility of small items in a single image. However, the complexity of the layout algorithm can make it difficult to visually explore the data and comprehend the tree map. Size. The larger data set size is more difficult to understand because more rectangles cause higher visual complexity. Labels. Absence of node labels or limited display of the labels in screen space can cause difficulty in understanding the tree map. Legend. A color legend can be used to represent value ranges visually. The absence of a color scale can lead to barrier in tree map interpretation. In this image shows most frequently used visualizations in VLAB paper. It's evident from this figure that the tree map design features several characteristics that distinguish it from the other most popular visual designs. First of all, tree maps are not based on a simple Cartesian coordinate systems and features labeled and numbered axes like the other visual layouts. Tree maps use a layout algorithm to guide the placement of rectangles. Also, Treemap is the only design that presents hierarchical data and can be used to display most individual data samples. Because of presented differences, Treemap can be viewed as more complex to understand than the other designs. Treemap literacy in the classroom. We explore how effective students were at creating a tree map by looking at the historical results of the information visualization assignment in 2018 and 2019. We gave out homework assignments to the students for our data visualization module. They were required to create 5 different visualizations for a given data set. We searched to find evidence of the students' strengths and weaknesses in generating the tree maps, as well as their level of comprehension and interpretation. We drive criteria, shown on the left side of this image, enable the assessment of tree map literacy. The criteria consist of questions examining which tree map features are understood by the students, such as the data hierarchy, internal node, leaf nodes, labels and legends, and color mapping. We can see that on the histogram in 2018, 68 students out of 85 submitted a tree map design, and 58 of them stated correctly what color was mapped to in their design. However, only 33 students could describe what the internal node size was mapped to. In this one, in 2019, we asked students to create a tree map image for a given dataset in addition to creating 5 different visualizations. Similar to 2018 results, students answer questions about the data hierarchy, leaf nodes, and color-related questions correctly more than questions on internal nodes. Only 26 students could describe internal node size correctly. Also, they were not very successful in providing unique observations and the correct name of the tree map layout. This investigation on tree map literacy provides insight into students' tree map literacy skills and enhances our knowledge of what they struggle with the most during the tree map construction. This evidence illuminates identifying the barriers to the tree map literacy and guides the development process of our tree map educational application. We develop a tree map visualization literacy test to measure a user's tree map literacy skills and identify the barriers to tree map comprehension. I'm going to show you the video to introduce our tree map literacy test.
We developed a Treemap visualization literacy test to measure a user's Treemap literacy skills and identify the barriers to the comprehension of a Treemap. We search for Treemap examples to establish a test with diverse Treemap designs for users with varying level of Treemap literacy. Answering Treemap literacy test questions require the evaluation of multiple factors on the Treemap simultaneously. Therefore, questions were classified to identify how users perform in interpreting the Treemap features. Each example is accompanied by a brief explanation of the Treemap image, and multiple choice questions.
We design a novel pedagogical application. This application facilitates both teaching and learning of tree maps and advances tree map visualization literacy. I'm going to show you the video of the software.
The Treemap application aims to facilitate understanding of a hierarchical data structure and support correct observation by displaying the data correspondence between a traditional tree structure and a Treemap layout simultaneously. On this software, we display a historic health dataset called Project Tycho, provided by Pittsburgh University. On this tree view, the US is divided into 5 regions to build the hierarchy. When the rectangle is highlighted via mouse over on the tree view and the corresponding rectangle on tree map is highlighted. The internal node can be expanded by subdividing the region to individual states in the region. This gives a field layout process of the tree map. Also, states are subdivided to different years. The number of people diagnosed with the disease is shown on the tooltip. We can navigate to see the different corresponding and move around the different levels of the hierarchy. Moreover, we can display another disease and change the color scale. Colors represent the number of people with disease, mapped to years, states, and regions.
We designed a classroom-based user study to evaluate the participants' Treemap literacy and the effectiveness of our pedagogical Treemap software. We provided our Treemap visualization literacy tests as pre and post tests. Some 25 students participated in the study. We described the procedure of our study and provided all participants with the pre-test Treemap questionnaire. After the completion of the pre-test, we randomly sample half of the participants to be allocated to the software group and a slides group. The participants in the software group were provided with a Treemap software demonstration and given time to interact with the educational Treemap tool. The slides group was shown only traditional Treemap slides used for teaching Treemap concepts. After completion of the two individual sessions, all participants were given the post-test questionnaire. Both pre and post-test sessions were 20 minutes long. Before completing the user study, participants answered 12 interview questions referring to their background, to test questions, and the Treemap software. According to our quantitative analysis of test data, the pre-test results didn't differ significantly between two groups of the students. Students attended the slide session answered correctly on average 62% of the pre-test questions, and the students in the software group answered 72% of these questions correctly. However, the results of the post-test were significantly different between two groups. Students attended the slide session answered correctly on the average 79% of the post-test questions, while the students who interact with the software perform much better. They answered correctly 89% of the questions. Overall, there was no significant difference between these two groups of the participants with regards to the improvement of their Treemap literacy level. Both groups have seen on average 17% improvement in their results from pre-test to post-test. However, participants in both groups answered the post-test intervention test questions faster than the pre-test questions. We classify questions based on the Treemap features, such as hierarchy, leaf nodes, color, label, and layout algorithm, to test where they struggle at most to comprehend Treemaps. I will show the question classification on the table in the next slide. Results don't show any significant difference between the two groups taking the pre-test for any of these five categories. But for post-test, participants in the software group perform much better in the questions related to the color, leaf nodes, and layout algorithms, while there was no difference in the questions testing hierarchy and labels for both groups. We conducted a thematic analysis using the feedback gathered from the interview about the literacy test and the Treemap tool. We identified 5 themes for the literacy test: hierarchy, labels, colors, layout, and the size that shows strong links with our hypothesis. One of the participants said for the Treemap images provided in the literacy tests, the more data being represented translated into more dense Treemaps, which made certain things hard to spot. That refers layout algorithm. The Treemap contains many boxes that are hard to see. That refers to data size. Another student said it wasn't clear how to compare the nodes and sometimes too many colors. That refers color. From the feedback on the Treemap tool, two themes were identified: hierarchy and interaction in active learning. A participant said about the software It breaks the tree down so you can only view what you want to see, and I can see the relationship and the categories of different data. That refers the hierarchy shown on the Treemap tool. Another participant said the visual feedback when hovering and the pop-up were helpful, and hands-on approach was effective. That shows the interaction and active learning. The table indicates questions rank from the most difficult to the easiest based on the number of correctly answered questions. Also, I mentioned earlier, it shows classification of every question based on the three map aspects that are necessary to comprehend for answering the questions correctly. Contrary to our initial belief, questions might focus on one aspect. Actually, questions require a user to understand three or four tree map features simultaneously. Some participants with data visualization background and availability bias might have played a role in shaping our findings as the participants' recruitment happened over the summer period. Future work: improving the literacy test with a wider variety of data and Treemap visualization design can be a good future research. More studies to reinforce the educational tool can be conducted with a diverse group, including more participants can be another future work. As a further research with participants from non-computer science fields for investigating the influence of users' familiarity with tree maps would be very interesting. For the educational tree map tool, providing labels for each rectangle directly on the software and enabling to view large data set with a different layout algorithm would be a good future works. Thank you so much for your attention.